All right, so thank you again to Taylor for inviting me to present. As you said, my name is Kyle Harrington. I am Dr. Amin Mustafa's assistant in extension in field crops IPM, and I'll be helping with the IPM aspects of the Urban Ag and Beginner Farmer program as well. I was born and raised in Arizona agriculture. I've lived here my entire life. Grew up with agricultural clientele and family friends. I'm also a PhD student in entomology and insect science, focused in agricultural integrated pest management with a minor in ag and natural resource economics. So at Cooperative Extension, we do efficacy trials, economic injury levels and thresholds, proof of concepts, variety trials. We look at yield components, genomics, nutrition value. The list really goes on. Cooperative Extension we run the full gambit here. So I am primarily a commercial scale field crop researcher. However, the concepts and practices of IPM can be scaled down or up to fit any producer's needs. So let's jump into it. So what is IPM? As soon as I tell people I work in IPM, they say, oh, you're the bug guy. And they say insect pest management. Well, that is my academia, but in Cooperative Extension, we are integrated pest management, and that is a true definition of the term. We work with a lot of pests, but what actually defines a pest, or more correctly, who defines a pest? So we do. As Kai mentioned, it is something that we deem undesired. So corn, we would not consider a pest, but if we have corn in our alfalfa fields, it's all of a sudden a pest. So IPM is integrated pest management, and it's a sustainable science-based decision-making process that combines biological, cultural, physical, and chemical tools to identify, manage, and reduce risk from pests, and pest management tools and strategies in a way that minimizes overall economic, health, and environmental risks. So as you can see here, there's a nice graph. It's continued to evolve over time, and it's really grown to show that it's not only, IPM is not only for the agricultural community that we impact, but it also includes the end users and the environment and how they are all interconnected. So as Taylor mentioned before all this is just kind of a sneak peek. So we could really get into the history of IPM, and I could talk about ancient Sumerians and how they use sulfur compounds, planting diagrams, how people have used soap as insecticides, how in the 1600s they used tobacco, which was nicotine and arsenic. In the 1930s, we moved to synthetic compounds. So if there's a history on IPM, we can definitely talk about that if that's an interest to other people at a later date. So we look at IPM as a structure. We look at first trying to see what we can do as far as avoidance, crop and nutrient management, alternative hosts using resistant varieties, pest and biology and ecology, natural enemy conservations. We definitely look at pest outbreaks and detections. We'll try and monitor our crops as much as we can. And then we're going to base decisions on action and economic thresholds. Economics is a huge part of IPM. If there's no economic way to manage something, then it's hard to say whether we should really be managing it or working around it in a different way. So we should acknowledge the structure of this management system. It is based in crop management, biological and cultural control, as well as other preventive practices. If we're missing key elements in crop management, biological and or cultural controls, the system can become inherently unstable and unsustainable. So today we'll look at a couple of components of IPM. So we'll go through prevention, identification, monitoring, assessment, planning or actions to planning of actions, and evaluations. So first we'll look at prevention. Prevention may eliminate need for further action. It can mitigate future problems and inevitably future costs. So again, as I mentioned, economics is a huge component. We don't want to wait to do things. Early action could save a high amount of costs later on. So as you see along a ditch bank, if we don't manage these weeds early, we're going to end up with weeds in our crops. Some weeds can produce over thousands of seeds, if not more per plant. So the quicker you can get on top of them, the better you're going to be able to manage them later on in the future. Another one that you can look at is wood laying on the ground or near your growing area might entice carpenter ants to take up residence. So again, the more prevention we can do, we can save ourselves a lot of time and a lot of money later on down the road. Identification. IPM relies on sustainable measures in which we target specific pests. It is very important to know what you are looking at. Not all insects are pests, and not all pest insects are pests in everything. So the image that you see is a lygus bug in forage alfalfa. There could be thousands of them in the field. Well, what should I do to treat them? We have a couple of trials that I was called by the industry client and said that there were a lot of lygus bugs in their alfalfa forage and we should manage them, we should spray them, they're doing damage to them. I had to inform them that we're going to do nothing because they are not a pest in forage alfalfa. They're a pest if you want to do seed alfalfa, which was not their intention. Now, if you have lygus in your cotton when bolls are setting, that's another story that might require action. So again, not all pests are pests in everything, and identification is very important. So know what you're looking at before you make a management decision that could cost you money. You could be knocking down beneficials with depending on what product you're going to use. So identification is key. Know what you're looking at, use cooperative extension, use the resources to find out exactly what you have in your field and whether it's something that you're going to need to manage for. Monitoring. So when do we need to monitor? Are we only going to monitor as soon as we have germination in the field? Or are we just going to look at it at harvest and hope that we got through it okay and then just maybe knock out some stuff at the end? No, we should be constantly monitoring for pests throughout the season. Agriculture is not a plant and walk away type of industry. So we are constantly going to be in the field, constantly looking at your crops. You could have something like cutworms on seedlings, or you could have aphids on a harvestable product. Again, constantly monitoring your crops. It is a 7-day-a-week, 365-day-a-year job. Assessment. So we've correctly identified a pest and we've been monitoring it appropriately. So now what do we do? So we should take immediate action, right? Maybe, maybe not. Has the pest populations reached thresholds that justify that action? You could be managing too early, and depending on what product that you use, you could have pest resurgence and then would justify a second application. So look into thresholds, look into when to properly apply products or take management decision practices. You could have high predatory and natural beneficial insect populations that may be able to manage the pest populations on their own. If you use a broad spectrum insecticide, such as a pyrethroid or a pyrethrin, so organic or synthetic, you may knock down your pest populations, but you're also going to knock down your beneficial populations. And those pest resurgences are usually quicker than the beneficials are to help you out in your fields. So if we are going to take action, there's a couple of things that we look into in IPM. So you have cultural preventative measures, such as introducing your resistant varieties, pruning strategically and altering plant nutrition. One that they've done here is planted sweet onions next to their broccoli so that the onions will actually act as a deterrent to pests in the broccoli. We have physical methods such as putting up barriers, placing screens, and using mulches. I'm sure a lot of you are familiar with bagging or tarping, whichever terminology you want to use. We have biological controls, such as introducing beneficial organisms, predatory species, and microbial controls. And if you so choose, pesticides can be chosen for compatibility with other methods. The best strategy largely depends on the particular type of pest you are dealing with and your personal management practices that you choose to have on your farm. So since we talked about pesticides, I have a little pesticide segue. Side, the suffix means to kill. These are all chemicals, even if they are considered organic, they are all chemicals that kill the desired pest, but can also harm or kill off-target organisms if they're broad spectrum. So I have the example of Pyganic and Warrior 2. So one is organic, one is synthetic. One is a pyrethrin, one is a pyrethroid. Both act on sodium channels. They are sodium channel modulators. All animals have sodium channel modulators. We are animals too. So just because something is organic or deemed that way, it could have the exact same mode of action, and we'll get into that in a little bit. It could have the same mode of action as a synthetic that we're choosing not to use. So when it really comes down to it, and I put this in larger text and bold, please read and follow the label of all of the products that you are going to use. The label is the law. Literally, it is the law. And it is there to help protect the applicator, the bystander, the other animals, the other organisms, the environment, and the consumer. So once we've taken action, we want to evaluate. Follow-up monitoring is crucial. Document what worked and what doesn't work. If you used a pesticide, document it and at what rate you used. A very key component when we're using pesticides and reducing pesticide-resistant issues, which is a key component of IPM, is to rotate your mode of action. So we talked about mode of actions. We saw on the previous slide that there are many different mode of actions. So if we want to be good stewards of product use, please rotate mode of actions so that we don't end up with resistant issues. So we've gone through a couple of components of IPM. We are cooperative extension, and we have information-based research that we have been giving to commercial clientele. And now that Taylor started up this program, we would like to obviously offer them to you as well. So I just kind of like to go through type of the science-based research that we do to be able to show you that what we're doing is at one more step of a level. We're not just treating one plant with one thing and one plant with another and going to make a diagnosis, will this work? There could be a lot of other factors at play. So we'll go through one specific type of trial that we do. I'll go through an efficacy trial that we do here and just kind of show you guys information that we present to you in the future is scientific-based research that we do here at Cooperative Extension. So a lot of the designs that we like to do are called randomized complete block design. So this, as we go through it, this is a hypothetical trial. I am just trying to show it to you in the best way that I can. But this could and has been an efficacy trial that we've done. So we have our different treatments that we will have in the field. So we can have mechanical treatments, we can have biological treatments, cultural treatments, and then say chemical 1 as an organic, chemical 2 as a synthetic, and the main point of efficacy. So there's a difference between efficiency and efficacy. I can test between an organic and a synthetic, and I can say which one is more efficient, but I cannot correctly say that one is more efficacious than the other. So efficacy has been used a lot recently, as we all know, in the news recently with what we're going through. So efficacy will require an untreated control. So again, for our efficacy trials, we will always have an untreated control to compare all of our treatments against. So we start, and you saw the plots here. So this would be monitoring for plots in a field. So this is one of those plots that we would go through. We're going to do a representative sampling of this plot. So again, there's going to be different forms of sampling for what crop you have. It could be 1 in 10 plants. I believe Chana answered yesterday to one of my questions that 10%. So if you're looking at certain row crops, that 10% could be a representative sample of what you're trying to do. I know a lot of people have decent sized farms. Even 2 acres is a lot to manage. So it can be very difficult to be looking at every single plant. I would recommend that you're looking at least 10% of your field where your crops are grown. So we do 180-degree sweeps in alfalfa. We could be taking 5 random leaves from corn plots, visual assessments. We've done this with pests and sorghum. The type of sampling will change to what type of crop you have and how you decide to manage them. So we'll take these samples, we'll place them in bags as you saw me doing there, and we'll bring them back to the lab. And after we've done our post-treatment, this is how we're going to monitor for our evaluation. So back in the lab, we're going to take them out of the bags. We're going to sort and do data collection. So again, depending on what crop we're looking at, in alfalfa, this could be aphids, could be weevils, could be hoppers. In corn, this could be mites. In sorghum, this could be sugarcane aphids. We can also be looking at beneficials. So we're looking at the ratio of how many beneficials to pests that we have, so we can basically evaluate, well, what level of beneficials do we have that can appropriately manage pest populations in the field. So raw data collection is very key in these days where we hold a lot of faith in cloud storage. I have many binders of raw data. Raw data are my Bibles. I need my raw data. So when we go through, again, with our alfalfa, our theoretical trial, we can go through and we can take yield components from this. We can take subsamples and do nutrient quality. So again, I recommend maybe not using just one product on your farm. Maybe try and use 2 products and see what works best for you. One product might work really well one year, depending on the environmental conditions and other variables. Excuse me. And also look at your nutrient quality. If you're doing fertilizer trials on your own farm, look and see which one might hold more nutrient contents for you. Maybe that's more desirable in the market and more economically valuable. I guess we have to wait till the end. Sorry, you have to watch me. So with that, we've taken samples back to the lab. We've collected data. So all of this that you see on the right-hand side, this was one trial that we've done over multiple years. So we collect a lot of data, and that's what we can do from the research side to help our clientele. That would be you now also. So we don't just look at one plant versus another. We are looking at multiple plots, and we are trying to do this over multiple years so that we can track the efficacy of products or management practices. So now that we're left with all of this data, that data needs to be analyzed. So we can have visual in the field, so I can visually see that one plant or one plot is reacting much better than other plots. But even within those plots that all look green, there could still be a very statistically different response from those treatments. So we will put them into a statistical software program, and we can actually get data out of them. So these are what are called an analysis of variance. So we are looking for the significance between treatments. Again, we are on our hypothetical trial train here, so do not take this completely to heart, saying that every single time, well, chemical 1 and chemical 2 are always going to be the best. Every scenario is completely different. Again, this is just a way that I can show the type of research and the type of analysis that we can do to help the end user, our clientele. So we can look at how the treatments have affected pest counts throughout the field, and we can also look and see how the treatments have affected our yield. So with analysis of variance, we look at any letter that is associated with the same letter is not going to be statistically different. So even though chemical 2 here is a little bit lower than chemical 1, they are not statistically different from one another. And then same from the other side. So with the B and C here, both the biological and the cultural treatment in this hypothetical scenario, both have a C in them, and the cultural has a D in it. So the biological is not statistically different from the cultural, and the cultural is not statistically different from the mechanical or the untreated control. So what do we do with this data analysis? Well, we hold education and outreach. So we hold workshops, clinics, tent talks to show and discuss our research with growers, industry representatives, and stakeholders. You are now part of our clientele, so we will be very happy to do this type of research and be able to show and discuss with you the type of research that we're doing. So even though we do this education and outreach, how do we know that people are actually listening or possibly implementing what results that we're showing? Surveys. Written surveys are one of the most powerful tools that we can have in Extension to be able to see what impact we're having. I don't necessarily have time to drive around to every single farm and gather this information. Therefore, online and written surveys during in-person workshops is the best way we can see if our research is ultimately impacting and being implemented by our growers. Certain things that we can find from these surveys are demographics, what type of people are showing up to our workshops. Another big one is suitability. I think that's a big part of this specific workshop in general. What type of information did we present was useful? What do people want to hear more about? And ultimately what we want to see. So we would like to see modification of practices based on the information that we present. So I could even pose to you the question of, will you change any of your practices after learning about today's topics? Hopefully you are all in the yes category. So with that, I would like to end. Thank you again for listening and being present for this. I believe the clientele in Arizona specifically has grown enormously, and I think this is going to be a fantastic program.